family grows. The city itself will be our playground. We'll use as we please, rewarding ourselves and punishing our enemies.
We've been looking for you, Miss O'Neill.
There is a new enemy, freaks of nature. Together, we will punish these creatures.
What the heck was that?
Looked like sort of a big turtle in a trench coat.
Awesome! I love being a turtle!
Wondering what model gives the best description of actual bonding in complex.
I believe the molecular orbital model gives the best description of the actual bonding in complex ions. In terms of this model, the d orbital splitting occurs since the orbitals are non-bonding and are raised in energy. Geez, I wish we can play with these actinides.
Play with them and learn chemistry at the same time.
Concentrate on the first row transition metals because they are representative of the other transition series and because they have great practical significance. The first row transition metals are scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, and zinc.
The transition metals show great similarities within a given period, as well as within a given vertical group. This difference occurs because the last electrons added for the transition metals are inner electrons. D electrons for the D block transition metals and F electrons for the lanthanides and actinides. These inner D and F electrons cannot as easily participate in bonding as can the valence S and P electrons. Thus, the chemistry of transition elements is not as greatly affected by the gradual change in the number of electrons as is the chemistry of the representative elements.
Transition metals behave as typical metals, possessing metallic luster and relatively high electrical and thermal conductivities. Copper is the second best conductor of electrical current, which explains copper's wide use in the electrical systems of homes and factories.
As you can see, iron is a thermal conductor.
That's not.
In forming ionic compounds with nonmetals, transition metals exhibit several typical characteristics. More than one oxidation state is often found. For example, iron combines with chlorine to form FeCl2 and FeCl3. The cations are often complex ions, species where the transition metal ion is surrounded by a certain number of ligands. Molecules are ions that behave as Lewis spaces. For an example of a complex ion, see page 896 of your Stephen Zumdahl chemistry book. Most compounds are colored because the transition metal ion in the complex ion can absorb visible light of specific wavelengths. Many compounds are also paramagnetic. They contain unpaired electrons.
Structural materials. Others, such as copper, gold, and silver, are relatively soft. Some transition metals react readily with oxygen to form oxides. Of these metals, some, such as chromium, nickel, and cobalt, form oxides that adhere tightly to the metallic surface, protecting it from further oxidation. Others, such as iron.
The transition metals can form a variety of ions by losing one or more electrons. Ionization energy increases gradually going from left to right across the period. Please refer to figure 20.2 on page 898 of Stephen S. Zumdahl Chemistry, 2nd edition. Transition metals ions characteristically form coordination compounds, which are usually colored and often paramagnetic. A coordination compound typically consists of two parts: a complex ion, which is a metal transition ion and a ligand, and the other part, a counter ion, which is an anion or cation, usually produced to create a compound with no net charge.
What about isomers?
Well, I'll show you, but it's getting late.
Okay, thanks. When two or more species have the same formula but different properties, they are said to be isomers. They contain the exact same types and number of atoms. The arrangements of the atoms different and leads to different properties. We consider two main types, structural isomerism and stereoisomerism. Of the two types of structural isomerism, we will consider coordination isomerism, which is the composition of the complex ion varies. For example, in this case, SO4 with -2 charge is coordinated to CR with a 3+ charge, and Br- is the counter ion. In the second case, the roles of these ions are reversed. In the second type of structural isomerism, linkage isomerism, the composition of the complex ion is the same, but the point of the attachment of the ligand is different. Two ligands can attach to metal ions in different ways, which can bond through lone pairs on the nitrogen or oxygen atom. For example, these two. In the first case, the NO2- is called nitro and attached to CO3+ through the nitrogen atom. In the second case, the NO2- is called nitro and is attached to CO3+ in the oxygen atom. Refer to figure 20.10 on page 912 of Zumdahl's Chemistry. Isomers have the same bonds but different spatial arrangements of the atoms. Geometrical isomerism occurs when atoms or group of atoms can assume different positions around a rigid ring or bond. An important example is shown here. Refer to page 913 in Zumdahl's Chemistry, figure 20.12.
Jeannie, thanks a lot, Jeannie. See you later.
No problem.
Boy, we're sure to get A's on this test.
Should and would. Do not worry, do not fear. Teenage Mutant Ninja Turtles are here. Yes, now you know the deal and feel the sensation. The beat, the melody, the raw vibration. Put together by Danny G and Yaka K. And you know with me, we're gonna lead you to the rhythm of the song so you may take it oh so strong. Remember to keep the soil fertile or you have to answer to the turtle. Ninja Turtle.
I mean, like,
Pull them up, okay? And then let them go, do it fast though.
Do it fast.
Yeah.
Like that?
Yeah, that'd be cool. Do it.
Okay, hold on.
And then make them go that way.
Man, why? Because he's gonna
Just have it go like this, go.
That.
Wait, I got your hand.
Oh, your hand.
Wait, let me do it so you won't get it. Okay, go ahead. Do it. Okay, that's cool.
Alright, so now we're gonna have
This
to come
is
back down.
up.
Or no,
This
do
is.
we film, now do we film the whole jump? Because
Yeah, film it like,
This is look of Ricky the four.
we'll put something together.
And Ricky go home.
yeah.
This is.
Go home.
What did he do?
He put his hands on Oh my god.
Tells a lot about my family.
Just kill me now. Where's the
Phillip, will you get out of here?
Where's the
Please.
elevator guy? Get him back.
Come on. Dad, can you tell Phillip to get out of here?
Except make it like, yeah, like this.
Phillip, will you... Phillip. Phillip.
Excuse me.
Phillip. Dad, will you get Phillip out of here? Whoa!
What's that?
Nothing.
Happened, diesel.
Nothing.
What's nothing? There's a plus.
That's great, Genie, but what about isomers?
Well, I'll tell you, but, you know, time is getting kind of short, so this will be our one last thing, okay?
Okay.
Alright. Thanks a lot, Genie. Well, see you later.
Anytime.
Pause.
Action.
We're all sure to get A's.
I agree. More species have the same formula but different properties.
Okay, I'm starting now.
What?
He's starting now.
Although isomers contain exactly the same types and numbers of atoms, the arrangements of the atom differ, and this leads to different properties. There are two main types, structural and stereo isomers. Okay. For example, coordination isomers. In the first case, SO is coordinated to CR and BR is counterion. In the second case, these are reversed. Okay, that's good enough.
Okay. No, film it with it on.
But I need the light though.
Film it with it on there, Jason.
Like
Well, he'll pop up.
5, Bruce,
Or
5,
we'll do it whatever. We'll see what happens.
and
see if it
Phil
looks
by house 5.
And science.
Okay, wait, move. Move.
Got it?
Yeah.
Okay. Now what?
That's it. That's it. We're out of here.
Do you want to draw? Can anyone draw? You could draw a picture of the genie and then write.
Should we?
No, let's just like write down. Add as the genie.
Oh yeah, now add it in. We could like have it flash
Okay,
in now.
yeah.
Skip.
Can anyone draw? If you could draw a good genie on there, that'd be cool.
I can't draw.
Neither can I.
B.
No.
I
Put starring.
flower.
Starring tab as the genie.
I could draw it. I could
Phillip, you're not my camera.
I could draw very good. Come on, don't tell him how we did. You're going to picture this
How do you spell
picture.
genie?
Okay. G-E-I.
I could.
I can't draw at all. I suck.
They don't know how to spell genie.
We'll put that, film it, and then we'll draw a little genie underneath on the next frame.
Let me
Like
draw
you did
it.
here.
Move.
Let me
Wait, have another
draw
guy
it.
in there.
Let me draw it. Let me draw it.
This is the same guy.
Let me draw it.
What? That's gonna be so
I
cool.
could draw it.
Like this. That'll be cool. Where's the tape?
If you have it hanging by the light, you could. And they'll see this like 3 years from now.
It's still filming, you know.
Is it? Okay.
Yeah, that's it.
How close could we get to the elephants without scaring them away? It's okay, Christy.
He must be the guard.
February 12th, 1991, 10:40 p.m.
The way he talked about my sister, that turns out to like the guy.